Hello, welcome back for the weekly recap for Digital Earth, Geography 149-150 for WVU. First, to recap the past week, the lessons from the third module. The main three components there are datums, coordinate systems, and projections, and the distinctions between those. Looking at each of those in turn, we start with the datum. The datum is how we are approximating or representing the actual shape of the Earth. So it's a simplified form of the topography and what we think the shape of the Earth is. There are two main kinds. There's some that are global. You may have come across the term WGS for World Geodetic Survey, looking at things like Google Maps or other online world maps. That would use one of those more global datums. There are also datums that are for particular continents or regions, like the North American datum 1983 or NAD 83. Between those two, that's what you will normally see for maps here in the US, either WGS or NAD 83. Of course, if you're working with a different part of the world, like China or South America, you would not want a datum optimized for North America. You would instead want one for China or South America or wherever you are working. Once we have our coordinate system, or our datum identified, we can then, in a sense, put numbers on it for the coordinate system to mark down the location of places on the Earth's surface. And that's what the coordinate system does. We can either have an absolute coordinate system, which is basically latitude and longitude. That again is going to work everywhere in the world. There is one global latitude longitude system. The other kind is a relative coordinate system, which you may see sometimes called a planar coordinate system. And it measures direction and distance, north and east, from what's called the false origin. Those only work, the relative coordinate systems only work for small parts of the Earth's surface. And so you'll have to make sure you have one that is set for where your map is located, or for where the data is located. Some common ones in the US, we have the state plane coordinate system, like the Indiana east and west zones that you had from the module review, or the West Virginia North and West Virginia South zones here in the state of West Virginia. The other system that you will see, and it's a system that has a series of zones all throughout the world, it's the UTM system. And we have UTM zones 17 and 18 north in West Virginia. So once we have our datum identified to figure the shape of the Earth or estimate that, then we can put the locations down with the coordinate system. We finally have everything ready to put it onto the map, and that's where the map projection comes in. The world obviously is three-dimensional. Maps are two-dimensional, whether they are on a piece of paper or whether they are on a computer or phone screen, is using two dimensions. To get that transformation from 3 to 2 dimensions, we need a projection. Projections come in 3 different broad categories of shapes. You have a planar projection, which is like putting a piece of paper flat on top of the surface of the Earth. They are most commonly used in the polar areas, both around the North Pole and the South Pole. The second type is a conic projection, which is kind of like putting a cone hat on top of a globe. And that's typically used for mid-latitudes. The third is a cylindrical projection, like wrapping a cylinder all the way around the globe, like at the equator, and it's often used for the equatorial regions. Those three those are what's common. There are exceptions. No matter whether your projection is planar, cylindrical, or conical, there are some properties that are preserved or distorted. Those 4 properties are the area or size of features on the map. So an equal area projection is going to have everything the correct size. Even if it is a weird shape, it is going to be the correct size. The second is preserving the shape, a conformal projection. Some things are going to be too big, some are too small, but the shape of everything is going to be accurate. And it is noteworthy that it is impossible, it is a mathematical impossibility to preserve both shape and size together. The other 2 properties that are preserved or distorted are more for specialized applications like navigation to or from an airport, and those are distance from the center point of the map. And so all those distances are going to be accurate. So if you're flying away from Boston and you want to know how much fuel you need, then you may want an equidistant projection centered on Boston. Last is direction. The direction from, again, that center point. So it is often possible in those particular ones to preserve both the direction and the distance from the center point together, or preserving the direction along with the size of things. There are, for those 4, where things are preserved or distorted, if you think back to the different shapes, everything is at its most accurate, everything is at its most preserved where the paper touches the globe, whether that is at the spot where the planar projection meets the globe, or the lines where the conical and cylindrical projections meet the globe. The last kind of projection is a compromise projection, which does not preserve anything perfectly, but in doing so it doesn't throw any of those properties really seriously out of whack either. So those are datums, coordinate systems, and projections. Looking forward to next week, the next module, looking at elements of map design, really seeing how cartography contributes to the field of geographic information science. And we'll look at the elements of a map and how they are properly laid out. Things like the main figure of the map, a north arrow, a scale bar, a legend. We'll also look at different kinds of maps, dot density, choropleth, proportional symbol, for example. And lastly, we will look at particular design choices for choropleth maps because they are so commonly used and so commonly misused. Things like when you're breaking up, say, the counties of West Virginia into 5 different colors, or 7, or 3, or 2, how do you decide things like how many groups to use, where do you put the breakpoints, and what color scheme do you use, and how those can make a map either effective or ineffective. So that is the recap and looking forward of the content. In terms of deadlines, you should have already submitted at the end of last week on Friday the 4th, submitted your module review and the blog post. Your comments for the next one are due Wednesday. And you have the next module coming up due Friday, September 11th, both the module review and the blog post. Lastly, and those of you in 149, there's also another lab due this coming Friday. And lastly, for general announcements, those of you, I hope you have already seen the announcement about the West Virginia University moving in-person classes to online, and getting all sorts of messaging about that. That does not affect this course because it was online from the beginning. Therefore, deadlines, due dates, and so on are as they had been. So as always, if you have questions, please feel free to reach out, to ask questions. If you have concerns about the content, you think you're not getting something, again, please let me know, please ask, and we can schedule a meeting or something so that everything is resolved and you're caught up and understanding things before the first exam coming up Friday, the 18th of September. Just to alert you, that is coming up. So again, thank you very much for listening. Have a wonderful day, and I will see you at the next review.